my name is Thor, Tanyakorn. I'm from Monday class Fundamental Math. Yeah. So today I'll be doing chapter 5.1, exponent and its functions. So before we move on to its function, we have to know what exponent is, so that we can manipulate them and work it out later. Okay, let's start off with some property of simple exponents. So the first exponent we'll be dealing with is power. Let's say that 2 to the power of x is a sort of exponent, yeah? So we have to know what are the properties that we can deal with. For example, if we do this, Okay, so if let's say I have to simplify this, what am I supposed to do? Let's say we look for a common root from common first. We can see that the only common here is 2 and 3 doesn't have any common. So to move it up, simply adding these 3 together, you will get 2 to the power of 3x. Simple. This is the basic property of the first exponent. Okay. Let's move on to a little bit of shape. So let's say that if this means that 2 is multiplied by x times, so what does this mean? This actually means this. Right. Okay. So what about, okay, let's say this is just a normal case of x. What if 2 to the power of 1 over x? A lot of you might be confused as how do I actually represent this thing without using power? The thing is simple. X here represents the roots. So this means that root x to the power root x2. Yep. So let's move on to some examples of the question that we usually face. First of all, let's do the simple manipulative function. Not exactly function, just simple thing. Simple simplification. 2 to the power of 4, 2 to the power of 1 over 4. Nah, just make it 5. This thing bracket to the power of 3. To solve this, simply we add 4 to 5, which is 9. Get this. However, this is not the end of it. Since it's to the power of 3, this actually means that 2 is to the power of 27. Because here, basically it's 9 times 3. Right. And to get 9, it's basically this 4 plus 5. So this is a simple manipulative to make the simplest form, easy for calculation, easy for showing. Okay. Moving on to the root property. Let's say that this is another exponent, x multiplied by root x. What you would get is x itself without anything. Okay, to show that why, a lot of people would wonder why. Why is that so? How come it's ux and not other thing? To represent it clearly, it's actually quite similar to previous cases. X to the power of 1/2 multiplied by x to the power of 1/2 would yield you x. Simply because half plus half gives you 1, which is x. Let's look on at some case, but what about this? To simplify this, first we can see that there's only two common x, and the rest being y and z. So to multiply them together, you have to first see the common between the two. So this we will know that this would yield 2x. And since this and this have nothing in common, but due to the property, we can actually do this. So this is a simplified form of this for easy understanding. Basically, if a lot of you wonder why is it that it's like this, it's because this actually represents this. They are the same. They yield the same result, so it doesn't matter. So the more severe case of like, if I say let x be negative 11 or 17. Yeah. So how do I represent this? Actually, it's simple. First, you can see that it's negative. Once it's negative, this thing will be at the bottom. So since there's no coefficient, let's say the coefficient is y. We leave y here. X will be here. Once they are here, you can get your negative sign. 17, the denominator itself will be the root. So like root 17, you can see. Then x will be the power of the. Okay. So here's the result. This is what you will get. If it's the power of this. Remember, when in doubt, convert the root to the power. For easy manipulative purpose, this is always much easier than doing this and this. Right, moving on to the function. The shape of this function will look like this. On the other hand, the shape of this will look like this. Where this being 1, this being negative, this being positive. It's simple. Okay, to show that this is true, let me substitute in the number. The problem is, in this case, let's say this is a y function. The y function will never be 0. Mainly because that the result, whatever you obtain of this number, this thing won't ever be 0. Let's say if I let x be 0, then y itself would be 1, which is the intersection, which is here. However, if I let x be negative, as you know that anything negative will actually result in this. For example, if it's negative x. Let x be some really, really big number, negative 100. So the result we would get is like y equal to 1 over x to the power 100, and 2 to the power 100. Which you can see you get absurdly close, you will get really, really close to the x-axis, but it will never touch the x-axis. Therefore, it wouldn't be 0. So as you can see. On the other hand, if you like, if x is a positive number, the graph will increase exponentially. Right? So another example will be if x is just 100 itself, then y will be equivalent to 100. Yep. This is the result. However, don't be confused though. A lot of people confuse that this equal to this. They are not the same. This thing will yield a parabola, right? With the origin at 0. They are not the same. So be careful. Okay. Okay. So the next one exponent is e to the power of x. Well, actually you don't counter this much because this is a bit tough and you have to do logarithm to solve it. But yeah, it's basically worked the same way as 2. Same way. We just said e, take e as a number, so you didn't have to be problems. So. Moving on, let's solve some problems that you usually face in their assignment and studies. The one that usually came across From afar, this looks really complicated though. So to make it less confusing, we work on for the innermost part of the bracket. Like I said, 4 plus 5 get 9. 9 times 2 you get 18. So you end up with, no, you can't, oh, sorry. You can't add them together, they're x and y. So you leave it as it is. So it's 2 times 5 and 2 times 4. So you get x to the power of 8 and y to the power of 10. So here 2 and 3 can add together, you get x to the power of 5, right? And you leave y out. Okay, but it's not simplified yet. As you can see, there's still common things you can do. You add 8 to 5, same thing. You add 10 to 5. So you will get 13, x to the power of 13 and y to the power of 15. Right, these are the problems that we usually face. Although they're complicated, if you work it out from innermost to the outermost, it's not that difficult to obtain the answer. Okay, with this, I hope this helped. Thank you very much for your attention. Good luck for your exam.